हेलो। तो आई होप मेरी आवाज़ आ रही होगी अभी। शुरू करते हैं। आज ग्रुप 15 और 18 पढ़ेंगे क्योंकि बहुत लंबा है ग्रुप 15 वाला पार्ट ही। इस वजह से वो दोनों पढ़ के ऑलमोस्ट 20-21 पेजेस का बैठेगा। इसलिए फिर अभी शुरू करते हैं। The P block elements. Diversity in chemistry is the hallmark of P block element, manifested in their ability to react with the elements of S, D, and F block, as well as with their own. In class 11th, you have learned that p block elements are placed in group 13 to 18 of the periodic table. This valence shell electronic configuration of NH2 NP1 to 6, except for helium, which has 1s2 configuration. The properties of p block elements, like that of other, are generally influenced by atomic size, ionization enthalpy, electron gain enthalpy, and electronegativity. The absence of d orbital in second period and presence of d or d and f orbitals in the heavier elements, starting from third period onwards, have significant effect on the properties of elements. In addition, the presence of three types of elements, metal, metalloids, and non-metal, bring diversification in the chemistry of these elements. Having learned the chemistry of elements of groups 13 and 14 in P block of periodic table in class 11, you will learn the chemistry of the elements of subsequent groups in this unit. Group 15 elements. Group 15 includes nitrogen, phosphorus, arsenic, antimony, and bismuth. As we go down the group, there is a shift in non-metallic character to metallic through metalloidic character. Nitrogen and phosphorus are two known metals. Arsenic and antimony are metalloids, and bismuth is typical metal. Occurrence: molecular nitrogen comprises 78% by volume of the atmosphere. In the Earth's crust, it occurs as sodium nitrates (NaNO3) called chili saltpeter and potassium nitrate Indian saltpeter. It is found in the form of proteins in plants and animals. Phosphorus occurs in minerals of apatite family. Okay, apatite family. ये मैं हमेशा भूल जाता हूँ. Minerals of apatite family. Ca9PO4 whole 6 dot CaX2, where X2 can be chlorine, fluorine, and OH. Example: fluoroapatite, that is Ca9PO4 whole 6, CaF2. Which are the main components of phosphate rocks? Phosphorus is essential constituent of animal and plant matter. It is present in bones as well as in living cells. Phosphoproteins are present in milk and eggs. Arsenic, antimony, and bismuth are found mainly as sulfide minerals. The important atomic and physical properties of this group elements, along with their electronic configuration, are given in table 7.1. Okay. So atomic number, atomic mass, then electronic configuration, ionization enthalpy, it is decreasing. डायरेक्ट ट्रेंड है, कोई एक्सेप्शन नहीं आया यहाँ पे अभी. फिर आयनाइजेशन एंथैल्पी भी ट्रेंड है, लेकिन बिस्मथ की अचानक से बढ़ गई. ये ऐसे आ गया मतलब. हम्म. और एक मिनट रुको, ये क्यों देखना है, सिर्फ फर्स्ट देखेंगे ना. ना बैड. One is the one that is actually important. हाँ, इलेक्ट्रोनेगेटिविटी जनरल ट्रेंड डिक्रीज हो रही है नीचे जाने पे. हाँ, कोवेलेंट रेडियस इंक्रीज हो रहा है एज यूजुअल. एटॉम आयनिक रेडियस भी इंक्रीज नहीं यहाँ पे है. अच्छा, ये क्यूबिक क्लोज पैकिंग, और ये क्या है? ए बी क्या है ये? सिंगल बॉन्ड बी. अच्छा, बॉन्ड एंथैल्पी का मतलब बॉन्ड लेंथ, बॉन्ड एनर्जी इसकी वजह से छोटा मोटा हो गया, इसलिए इसको ज़्यादा कंसीडर नहीं करते. मेल्टिंग पॉइंट्स के इसका बड़ा हो जाएगा बहुत, क्योंकि वाइट फोस्फोरस का दिया हुआ है. वाइट फॉस्फोरस का बहुत ज़्यादा होता है, वरना इन जनरल ट्रेंड ही जाएगा। और यहाँ पे ट्रेंड ही घूम गया फिर। ओके, बॉइलिंग पॉइंट्स सिमिलरली पहले बढ़ता ही जाएगा, ये तो ये घट गया, 37 हो गया ना। अरे घट गए, उठ गए यार। एंड डेंसिटी भी इंक्रीज हो रही है, इसको मार्क नहीं करते। ठीक है, ट्रेंड्स ऑफ सम ऑफ द एटॉमिक फिजिकल एंड केमिकल प्रॉपर्टीज ऑफ द ग्रुप्स आर डिस्कस्ड बिलो। The valence shell electronic configuration. The valence shell electronic configuration of these elements is ns2np3. This orbital of these elements is completely filled and p orbital are half filled, making this electronic configuration extra stable. Atomic and ionic radii. Covalent and ionic. In a particular state, radii increases in size down the group. There is a considerable increase in covalent radius from N to P. However, from arsenic to bismuth, only a small increase in covalent radius is observed. This is due to the presence of completely filled D and or F orbitals in the heavier members. Ionization enthalpy. Ionization enthalpy decreases down the group due to the gradual increase in the atomic size. Because of extra stable half-filled p orbital, electronic configuration and small size, the ionization enthalpy of group 15 elements is much greater than group 14. क्यों होती है ये? extra stable half-filled p orbital, electronic configuration and smaller size, ionization enthalpy of group 15 is much greater than group 14. ठीक है. The order of successive ionization enthalpies as expected is 1 is greater than 2 is greater than 3. Electronegativity. Electronegativity values in general decreases down the group with increase in atomic size. However, among the heavier elements, the difference is not that much pronounced. Physical properties. All the elements of this group are polyatomic. Dinitrogen is a diatomic gas, while all other solids, while all other are solids. ठीक है. Metallic character increases down the group. Nitrogen and phosphorus are non-metal, arsenic and antimony are metalloids, and bismuth is a metal. This is due to the decrease in ionization enthalpy and increase in atomic size. So decrease in ionization enthalpy and increase in atomic size. इसकी वजह से स्टेट का डिफरेंस आता है, ओ सॉरी, मेटेलिक और नॉन मेटेलिक कैरेक्टर का डिफरेंस आता है. The boiling points in general increases from top to bottom of the group, but melting point increases up to arsenic and then decreases up to bismuth. Arsenic तक हमारा ये boiling point बढ़ा, ये रहा, और उसके बाद घटा. Chemical property, oxidation state and trends in chemical reactivity. The common oxidation state of these elements are -3, +3, and +5. Tendency to exhibit -3 oxidation state decreases down the group due to the increase in size and metallic character. In fact, last member of the group bismuth hardly forms any compound in -3 oxidation state. The stability of +5 oxidation state decreases down the group. The only well-characterized bismuth 5 compound is BiF5. The stability of +5 oxidation state decreases and that of +3 state increases due to inert pair effect down the group. Nitrogen exhibits +1, 2, and 4 oxidation state. Also, when it reacts with oxygen, uh, नहीं है. ठीक है. हाँ, फिर से वही. हाँ. Phosphorus also shows +1 and +4 oxidation state in some oxo acids. In case nitrogen, all oxidation state from 1 to 4 tend to disproportionate in acidic solution. Oh, okay. For example, ठीक है? Similarly, in case of phosphorus, nearly all intermediate state disproportionate into +5 and -3, both in alkali and acids. ठीक है. However, plus deoxidation state in case of arsenic, antimony, and bismuth becomes increasingly stable with respect to disproportionation. Nitrogen is restricted to a maximum covalency of 4 since only 4 1s and 3p orbitals are available for bonding. The heavier elements have one vacant d orbital in the outermost shell, which can be used for bonding, that is covalency, and hence expand their covalence, as in PF6 minus. Anomalous properties of nitrogen. Nitrogen differs from the rest of the members of this group due to its small size, high electronegativity, high ionization enthalpy, and non-availability of d orbitals. Nitrogen has unique ability to form p-pi multiple bonds with itself and with other elements having small size and high electronegativity. Example C. Carbon and oxygen. Heavier elements of this group do not form p-pi bonds as their atomic orbitals are their atomic orbitals are so large and diffuse that they cannot have effective overlapping. ऐसे ही था कार्बन वाले केस में मतलब ग्रुप 14 में भी. Thus nitrogen exists as diatomic molecules with a triple bond, 1s and 2p between two atoms. Consequently, its bond enthalpy 941.4 kilojoule per mole is very high. On the contrary, phosphorus, arsenic, and antimony form single bonds as PP, AS, and SB, while bismuth form metallic bonds in elemental state. However, the single nitrogen-nitrogen bond is weaker than single phosphorus-phosphorus bond because of high inter-electronic repulsion on the non-bonding electrons, owing to small bond length. As a result, the catenation tendency is weaker in nitrogen. Another factor which every single NN bond is weaker than PP bond because of high interelectronic repulsion of non-bonding electrons. इसमें पूरा का पूरा पेयर हो गया इस वजह से वीक हो जाएगा सिंगल बॉन्ड एज अ रिजल्ट टू स्मॉल बॉन्ड. Another factor which affects the chemistry of nitrogen is the absence of d orbital and in its valence shell. Besides restricting its covalency to 4, nitrogen cannot form d-pi-p-pi bond as heavier metals can. Examples R3p double bond O and R3p double bond CH2. R is equal to alkyl group. Phosphorus and arsenic uh, can form d-pi bonds also with transition metals when their compounds like PC2H5 whole thrice and arsenic C6H5 whole thrice act as ligand. Reactivity towards hydrogen. All the elements in group 15 क्या था? All the elements in group 15 form hydrides of type EH3 where E is equal to N nitrogen, phosphorus, arsenic, antimony and bismuth. Some of the properties of these hydrides are shown in table 7.2. The hydrides show regular graduation in their properties. The stability of hydrides because decreases from NH3 to BiH3. Okay, stability of hydride decreases, which can be observed from their bond dissociation enthalpy. Consequently, the reducing character of hydrides increases. Stability decreases, reducing character increases. Ammonia is only mild reducing agent, while BiH3 is strongest reducing agent. Ammonia is mild reducing agent, while BiH3 is strong reducing agent among all the hydrides. The basicity also decreases in order. NH3 is greater than PH3 is greater than ASH3 is greater than SBH3 and is greater than or equal to BiH3. तो यहाँ पे मेल्टिंग पॉइंट्स के ऑर्डर हैं जो कि ऑर्डर है नहीं इसमें सेट, पहले डिक्रीज हो रहा है फिर इंक्रीज हो रहा है. सिमिलरली बॉइलिंग पॉइंट, बॉइलिंग पॉइंट में भी ऐसा डिक्रीज हो रहा है फिर इंक्रीज हो रहा है. डिस्टेंस तो इंक्रीज ही होना चाहिए, इंक्रीज ही हो रहा है. HEH एंगल इट इज डिक्रीजिंग. फिर डेल्टा एच ऑफ फॉर्मेशन, इससे एनर्जी रिलीज होगी और उनमें एनर्जी लगेगी, तो दिस विल बी वेरी गुड. फिर डेल्टा डिसोसिएशन में बहुत ज़्यादा एनर्जी लगेगी, फिर कम 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 होती जाएगी. ठीक है. द रिएक्टिविटी द नहीं आएगा. Reactivity towards oxygen. All these elements from two types of oxides, E2O3 and E2O5. These oxides in higher oxidation state of the element is more acidic than that in the lower oxidation state. Their acidic character decreases down the group. The oxides of type E2O3 of nitrogen and phosphorus are purely acidic. That of arsenic and antimony amphoteric, and those of bismuth are predominantly basic. Reactivity towards halogen. These elements react to form two series of halides, EX3 and EX5. Nitrogen does not form pentahalide due to the non-availability of d orbitals in its valence shell. Pentahalide are more covalent than trihalides. ठीक है. Pentahalides are more covalent than trihalides. All the trihalides of these elements, except those of nitrogen, are nitrogen are stable. In case of nitrogen, only NF3 is known as stable. Trihalides, except of BiF3, are predominantly covalent in nature. Reactivity towards metals. All these elements react with metals to form their binary compound, exhibiting -3 oxidation state, such as Ca3N2 calcium nitride, Na3P2 calcium phosphide, Na नहीं वहाँ पे सी था, Na3AH2 sodium arsenide, Zn3Sb2 zinc antimoide, and Mg3Bi2 magnesium bismuthide. Bismuthide. pH has lower boiling point than NH3. Unlike NH3, pH3 molecules cannot associate through hydrogen bonding in liquid state. That is why the boiling point of pH3 is lower than NH3. अब आगे हमारे compounds of D block और P block group 15. Dinitrogen. Preparation. Dinitrogen is produced commercially by liquefaction and fractional distillation of air. Liquid dinitrogen, boiling point 77.2 Kelvin, distillates out first, leaving behind liquid oxygen, boiling point 90 Kelvin. In laboratory, dinitrogen is prepared by treating an aqueous solution of ammonium chloride with sodium nitrite, NH4Cl plus NaNO2 aqueous will give N2 plus 2H2O plus NaCl. Small amounts of NO and HNO3 are also formed. Okay, sorry. Small amounts of NO and HNO3 are also formed in this reaction. These impurities can be removed by passing gas through aqueous sulfuric acid containing potassium dichromate. It can also be obtained by thermal decomposition of ammonium dichromate. NH4 whole twice here 2O7 on heating will give N2 plus 4H2O plus C2O3. Very pure nitrogen can be obtained by thermal decomposition of sodium barium azide. Sodium or barium azide. BaN3 whole twice will give Ba plus N3 3N2. Properties. Dinitrogen is a colorless, odorless, tasteless and non-toxic gas. Nitrogen atom has two stable isotopes, 14N and 15N. It has very low solubility in water, 23.2 centimeter cube per liter of water at 273 Kelvin and 1 bar pressure. Low freezing point and boiling point, and low freezing points and boiling point. Dinitrogen is rather inert at room temperature because of high bond enthalpy of N triple bond N. React, uh, Reactivity, however, increases rapidly with rise in temperature. At higher temperature, it directly combines with some metal to form predominantly ionic nitrides with their non-metallic covalent nitrides. A few typical reactions are 6LiN2 on heating will give 2Li3N and 3MgN2 will give Mg3N2. It combines with hydrogen at about 773 Kelvin in the presence of catalyst Haivybash process to form ammonia. N2 gas plus 3H2 gas at 773 Kelvin will give NH3 gas. Delta H formation is minus 46 kilojoule. Dinitrogen combines with dioxygen only at very high temperature, about 2000 Kelvin, to form nitric oxide, NO. N2 plus O2 will give 2NO. Uses. The main use of dinitrogen is in the manufacture of ammonia and other industrial chemicals containing nitrogen. Example, calcium cyanamide. It also finds use where an inert atmosphere is required. Example in iron and steel industry. Inert diluent for reactive chemicals. Liquid nitrogen is also used as a refrigerant to preserve biological material, food items, and cryosurgery. And in cryosurgery. Why is N2 less reactive at room temperature? क्योंकि bond enthalpy इसकी बहुत ज़्यादा है. Ammonia preparation. Ammonia is present in small quantities in air and soil where it is formed by decay of nitrogenous organic matter, example urea. N2CO and NH2 plus 2H2O will give NH4 whole twice CO3, which will change to 2NH3 plus H2O plus CO2. On small scale, ammonia is obtained by ammonium salts, which decompose when treated with caustic soda or calcium hydroxide. ठीक है. On large scale, ammonia is manufactured by Haivybash process. In accordance to Lee-Chatterley's principle, high pressure would favor the formation of ammonia. The optimum condition for the production of ammonia are pressure of 200 into 10 power 5 Pascal, about 200 atm, the temperature of 700 Kelvin, and the use of catalysts such as iron oxide with small amount of K2Al2O3. Iron oxide with small amounts of K2O and Al2O3 to increase the rate of the attainment of equilibrium. The flow chart of the production of ammonia is shown in figure 7.1. Earlier, iron was used as a catalyst with molybdenum as a promoter. Okay, iron catalyst और molybdenum as promoter. मैं एक मिनट पानी भी लेके आता हूँ यार, बोतल मेरे दूसरे रूम में पड़ी हुई है. Just 30 seconds. Okay, I'm back. Let's go. Properties. Ammonia is a colorless gas with pungent odor. Its freezing point and boiling points are 198.4 and 239.7 Kelvin, respectively. In the solid and liquid state, it's associated through hydrogen bonds, and in case of water, as in case of water, and that accounts for its higher melting and boiling points than expected on the basis of molecular mass. The ammonia molecule is trigonal bipyramidal with nitrogen atom at the apex. It has three bond pairs and one lone pair of electrons, as shown in the picture. Ammonia gas is highly soluble in water. Its aqueous solution is weakly basic due to the formation of OH minus ion. NH3 plus H2O will give NH4 plus OH minus. It forms ammonium salt with acids, example NH4Cl, NH4O twice SO4, etc. As a weak base, it precipitates hydroxides, hydrated oxides in case of some metals, and in case of some metals, hydroxides of many metals, and their hydrated oxide in case of some metal, or hydroxides of many metals from their salt solution. For example, ZnSO4 plus 2NH4OH will give ZnOH whole twice white PPT plus NH4 whole twice SO4, और ये होती है white PPT और ये होती है brown PPT Fe2O3.XH2 मतलब rest. The presence of lone pair of electrons on nitrogen atom of the ammonia molecule make it a Lewis base. It donates the electron pair to form linkage with metal ions and formation of such complex compounds. Find application in detection of metal such as Cu2 plus and Ag plus. Okay. Cu plus वाला ये कॉपर वाला Cu2 plus वाला डीप ब्लू होगा कॉम्प्लेक्स, AgCl की वाइट पीपीटी होगी, और AgNH3 होल ट्वाइस Cl ये होगा कलरलेस, जो कि पीपीटी से वाइट से कलरलेस चला गया, पहले कलरलेस से वाइट आया था. Cool. So ammonia is used to produce various nitrogenous fertilizers, ammonium nitrate, urea, ammonium phosphate, ammonium sulfate, and in the manufacture of some inorganic nitrogen compounds, the most important one being nitric acid. Liquid ammonia is also used as a refrigerant. Why does NH3 act as a Lewis? क्योंकि उसमें lone pair होता है. Mention the condition required to maximize yield for high pressure or high temperature. How does ammonia react with solution of, ये डीप ब्लू कलर की पीपीटी बना, डीप ब्लू सोल्यूशन हो जाएगा, ब्लू से डीप ब्लू होएगा, गाढ़ा हो जाएगा. Oxides of nitrogen. Nitrogen forms a number of oxides in different oxidation states. The name, formula, preparation and physical appearance of these oxides is given in the table. ठीक है. पहले डाइनाइट्रोजन ऑक्साइड दैट इज N2O जिसमें ऑक्सीडेशन स्टेट +1 है, ये बनेगी NH4NO3 को जब हीट करेंगे तो N2O रिलीज होगी हमारी. कलरलेस गैस न्यूट्रल, इसमें मीडियम में एसिड और ब्लू सॉलिड, केडी है N2O3. ठीक है. एसिडिक और ब्राउन गैस तो NO2 होती है हमारी. फिर एसिडिक और कलरलेस जो सॉलिड या लिक्विड में होती है N2O4. फिर N2O5 एसिडिक और कलरलेस सॉलिड, +4 और +5 हो गया. इधर भी +4 है, और ये जब इसका डबल हो जाएगा तो सॉलिड हो जाएगा और कलर उड़ जाएगा इसका. गैस से सॉलिड बढ़ गया ना, ये तो सॉलिड ऐसे हम रख लेंगे थोड़ा सा. N2O3 ब्लू ब्लू है, बाकी बचा NO, इसमें +2 है, और 2NaNO2 प्लस FeSO4 ब्राउन रिंग कॉम्प्लेक्स तो नहीं हो गया थोड़ा सा, इसमें HNO3 होता है. ठीक है. तो यहाँ पे करते करते हमारा NO बन जाएगा. ये बड़ी लंबी है यार इक्वेशन पूरी, अगली बड़ा लंबा रिएक्शन है. 3 रिएक्टेंट 4 प्रोडक्ट. चलो. Lewis dot Lewis dot main resonance structure and bond parameters of these oxide are given below. N2O में यही चीजें याद रखना मेनली कि इसमें 4 बॉन्ड पेयर और 4 ही लोन पेयर है. हाँ, दो लोन पेयर और एक अनपेयर्ड है इसमें, NO में 15 इलेक्ट्रॉन है ना इसमें, एक अनपेयर्ड। फिर N2O3 में सारे पेयर्ड हैं और इसमें सिमेट्रिकल भी है, सिमेट्रिकल कहाँ ही है, सिमेट्रिकल नहीं है, और एक ऑक्सीजन सिंगल बॉन्ड से कनेक्टेड है। NO2 ये तो वो है रेजोनेंस स्ट्रक्चर है, इसमें भी एक इलेक्ट्रॉन फालतू है, एक अनपेयर्ड है। N2O4 में अनपेयर्ड वाला उड़ गया क्योंकि हमारे N2 ने कंबाइन कर लिया यहाँ से, इधर एक और N वाला लग गया पूरा। ठीक है, और ये सारे प्लेनर ही हैं। हाँ, बॉन्ड लेंथ दी हुई है, बट ये कहाँ याद रखेंगे सबकी, याद रख सकते हैं कि बॉन्ड एंगल किस हिसाब से होता है, किसका ज़्यादा किसका कम। फिर N2O5 का इसमें एक ऑक्सीजन बीच में है, NON बॉन्ड है इसमें एक, दैट माइट बी इम्पोर्टेंट, और ONO बॉन्ड 134 एंगल और NON 112 एंगल डिग्री। Why does NO2 dimerize? NO2 contains odd number of valence electrons. It behaves as a typical or odd molecule. On dimerization, it is converted into stable N2O4 molecule with even number of electrons. What is the covalence of nitrogen in N2O5? Covalence. Covalence कितने से बॉन्ड कर रहा है, एक दो तीन चार ही चार है, 4। नाइट्रिक एसिड. Nitrogen forms oxoacids such as N2H2 H2N2O2, hyponitrous acid, HNO2 nitrous acid, HNO3 nitric acid. Among these, HNO3 is most important. बड़ा लग गया बहुत नंबर आता है. In laboratory, nitric acid is prepared by heating KNO3 plus or NaNO3 and concentrated H2SO4 in a glass resort. NaNO3 plus H2SO4 will give NHSO4 plus HNO3. Substitution reaction हो जाता है. On large scale, it is prepared mainly by Ostwald process. This method is based upon catalytic oxidation of NH3 by atmospheric oxygen. 4NH3 plus 5O2 will give, in presence of platinum or rhodium gold catalyst, 500 Kelvin and 9 bar pressure, it will give 4NO plus 6H2O. फिर जब हम NO को रिएक्ट कराएंगे आगे तो ये बनाएगा 2NO2, फिर 2NO2 plus वाटर आ जाएगा हमारा 2NH3. NO thus formed is recycled and the aqueous HNO3 can be concentrated by distillation up to 68% by mass. Further concentration at 98% can be achieved by dehydration with concentrated H2SO4. Properties. It is a colorless liquid and boiling point of 355.6 Kelvin. Laboratory grade nitric acid contains 68% of HNO3 by mass and has a specific gravity of 1.54. In gaseous state, HNO3 exists as a planar molecule with the structure as shown. In aqueous solution, nitric acid behaves as a strong acid giving hydrogen and nitrate ions. HNO3 plus H2O will give H3O positive and NO3 negative. Concentrated nitric acid is a strong oxidizing agent and attacks most metals except noble metals such as gold and platinum. The product of oxidation depends upon the concentration of acid, temperature, and the nature of material undergoing oxidation. 3Cu plus 8HNO3 dilute will give 3Cu plus NO3 whole twice plus 2NO plus 4H2. अच्छा यहाँ पे NO2 बन रहा है, वहाँ पे NO बन रहा था, तो हमने कॉन्सेंट्रेशन बढ़ा दी, डाइल्यूट में ज़्यादा भी लग रहा था. Zinc reacts with dilute nitric acid to give N2O and concentrated acid to give NO2. तो कॉपर, यार ये तो पढ़ा हुआ है मैंने पहले 10th में. रेजन बनाएगा तो हाँ कॉपर वाला तो मेरे को याद आ गया। Some metals, example chromium, aluminium, does not dissolve in concentrated nitric acid because of the formation of passive film of oxide on the surface. Concentrated nitric acid also oxidizes non-metals and their compounds. Iodine is oxidized to iodic acid, carbon to carbon dioxide, sulfur to sulfuric acid, and phosphorus to phosphoric acid. Brown ring test. इसमें पढ़ने लायक तो ऐसे है नहीं कुछ, बस एक कॉम्प्लेक्स का फॉर्मूला काम आता है, पढ़ लेता हूँ, लेकिन एक बार ये पढ़ रहा हूँ सब कुछ तो। The familiar brown ring test for nitrates depends on the ability of Fe2 plus to reduce nitrates to nitric oxide when which reacts with Fe2 plus to form brown colored complex. The test is usually carried out by adding dilute ferrous sulfate solution to an aqueous solution containing nitrate ions, and then carefully adding concentrated sulfuric acid along the sides of the test tube. A brown ring at the interface between the solution and sulfuric acid layer indicates the presence of nitrate ions in the solution. NO3 minus plus 3Fe2 will give NO plus 3Fe3 plus, फिर FeH2O whole 6 2 plus NO जो यहाँ पे बना था, इससे बनेगा हमारा FeH2O whole 5 plus NO 2 plus, क्योंकि यहाँ पे Fe3 इसकी है प्लस 3 में है ना, हाँ प्लस 3। Yeah. Uses. The major use of nitric acid is in the manufacture of ammonium nitrate for fertilizers and other nitrates for use in explosive and pyrotechnic technique techniques. Pyrotechniques. It is also used for the preparation of nitroglycerin, trinitrotoluene, and other organic nitro compounds. Other major uses are in pickling of stainless steel, etching of metals, and as an oxidizer in rocket fuels. Phosphorus, allotropic form. Phosphorus is found in many allotropic forms, the important ones being white, red, and black. White phosphorus is translucent, a white waxy solid. It is poisonous, insoluble in water, but soluble in carbon disulfide. Okay, ये भी highlight नहीं हुआ ना अच्छे से। अरे क्यों है यार ये? Soluble in carbon dioxide and glows in dark, that is chemiluminescence. It dissolves in boiling NaOH solution in an inert uh, atmosphere of pH 3. pH 3 का inert interface होता है. White phosphorus is less stable and therefore more reactive than other solid phases under normal conditions. Because of angular strain in P4 molecules, where the angle is only 60 degrees, it readily catches fire in air and gives dense white fumes of P4O10. P4 plus 5O2 will give P4O10. यार ऐसा करते हैं, सिर्फ यही पढ़ लूंगा, काफी लंबा हो रहा है ऑलरेडी, 40 मिनट्स हो गए। चलो, it consists of discrete tetrahedral P4 molecules as shown in figure 7.2. मेरा हमारा P4, that is white phosphorus. Red phosphorus. It is obtained by heating white phosphorus at 373 Kelvin in an inert atmosphere for several days. When red phosphorus is heated under high pressure, a series of phases of black phosphorus is formed. Red phosphorus possesses into iron grey luster. It is odorless, non-poisonous, and insoluble in water, as well as in disulfide. Okay, insoluble is water and as well as disulfide, carbon disulfide. Chemically, red phosphorus is much less reactive than white phosphorus. It does not glow in dark. It is polymeric, consisting of chains of P4 tetrahedra linked in a manner as shown in figure 7.3. ये ऐसे करके bonds आएंगे और आगे chain बनती है. Black phosphorus has two forms: alpha black phosphorus and beta black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated in a sealed tube at 803 Kelvin. It can be sublimed in air and has opaque monoclinic or rhombohedral crystals. Opaque monoclinic and rhombohedral crystals. It does not oxidize in air. Beta black phosphorus is prepared by heating white phosphorus at 273 Kelvin. 473 sorry. यहाँ पे था रेड phosphorus. Under high pressure. It does not burn in air up to 673 Kelvin. Phosphine. Phosphine is prepared by reaction of calcium phosphide with water or dilute HCl. Ca3P2 plus 6H2O will give CaOH whole twice plus 2PH3. Ca3P2 plus 6HCl will give 3CaCl plus 2PH3. Okay. In the laboratory, it is prepared by heating white phosphorus with concentrated NaOH solution in an inert atmosphere of CO2. P4 plus 3 NaOH plus 3 H2O will give PH3 plus NaHPO2, that is sodium hypophosphite. अरे कलर कितना ज्यादा वो लग रहा है ना, मतलब येलो, बहुत ज्यादा येलो. ये फेड हो गया बहुत. ग्रीन ठीक है. इसको हम कुछ कर सकते हैं क्या, लाइक इसके कर्व एंड कर. ओह वाह, ये सही है. बॉर्डर को कर देते हैं. चलिए. हाँ हाँ ये ठीक है यार, ऐसे दिखेगा दूर से. चलो कुछ तो अच्छा है. When pure, it is non-inflammable but becomes inflammable owing to the presence of P2H4 or P4 vapor. To purify it from the impurities, it is absorbed in HI to form phosphinium iodide PH4I, which on treating with KOH gives off phosphine. और यहाँ पे सिंबल्स नहीं डले हुए. कर दूंगा. उसके बाद हम सिंबल्स बना देंगे. यहाँ पे प्लस आ जाएगा और यहाँ पे V प्लस आ जाएगा. नहीं, यहाँ पे एरो आएगा. प्लस, इधर प्लस, इधर प्लस. एरो को हम यहाँ पे डाल देंगे. बहुत बड़ा एरो. चलो. Properties. It is a colorless gas with rotten fish smell and is highly poisonous. It explodes in contact with traces of oxidizing agent like HNO3, Cl2 and Br2 vapor. It is slightly soluble in water. The solution of pH3 in water decomposes in the presence of light, giving red phosphorus and H2. When absorbed in copper sulfate or mercuric chloride solution, the corresponding phosphides are obtained. CuSO4 plus pH3 will give Cu3P2, that is copper phosphide, cuprous phosphide, नहीं cuprous, plus 3H2SO4. फिर HgCl2 plus pH3 will give Hg3P2 plus 6HCl. Phosphine is weakly basic and like ammonia gives phosphonium compounds with acid. Example pH3 plus HBr will give pH4Br. Uses. The spontaneous combustion of phosphine is technique used in Ohm's signal. Spontaneous combustion of phosphine is technically used in home signal. Containers containing calcium carbide and calcium phosphide are pierced and thrown in sea. When the gases evolved, burn and serve. Acha, in sea. When the gases evolved, burn and serve as a signal. It is also used in smoke screen. In what way can it be proved that pH3 is basic in nature? pH3 reacts with acid like Hi to form pH4i, which shows that it is basic in nature. pH3 plus Hi, P4i. Due to lone pair in phosphorus atom, pH3 is acting as lowest base in the above reaction. Bond angle in pH4 is higher than that in pH3. Why? Why? क्योंकि इसमें लोन पेयर की रिपल्शन है एक, जिस वजह से अच्छे से बॉन्ड एंगल नहीं आ रहा। हाँ, बॉन्ड एंगल नहीं खुल पा रहा, इसने दबा के रखा हुआ है उनको थोड़ा नीचे। वेरस यहाँ पे हमारा लोन पेयर लग जाता है और एक खुल जाता है। What happens when white phosphorus is treated with concentrated NaOH in presence of inert atmosphere? रेड phosphorus बन जाता है, राइट। एक और कौन सा था? व्हाइट phosphorus। यहाँ पे व्हाइट phosphorus दिस अंडर हाई प्रेशर और व्हाइट phosphorus एट दिस इन इनर्ट। हाँ ठीक है, यस, रेड phosphorus बन जाएगा। नहीं, कॉन्सेंट्रेटेड NaOH था ना, ये कहाँ था? ये रहा। ओ, फोस्फीन बनती है इससे, अभी अभी तो फोस्फीन पढ़ा यार, क्या यार, सो बैड। pH3, ठीक है। Phosphorus halide. Phosphorus form two types of halide. PX3 X is equal to FClBrI and PX5 X is equal to FClBr। हाँ, अच्छा यहाँ पे I नहीं आएगा क्योंकि I बहुत बड़ा होता है। Phosphorus trichloride PCl3. It is obtained by passing dry chlorine over heated white phosphorus. P4 plus 6Cl2 will give 4PCl3. It is also obtained by the action of trionyl chloride with white phosphorus. P4 plus 8SOCl2 will give PCl3 plus 4SO2 plus 2H2Cl2. Obtained by the action of thionyl chloride, that is SOCl2. इससे बनेगा हमारा PCl3, 4SO2 and 4H2Cl. Properties: it is colorless, oily liquid, and hydrolyzes in the presence of moisture. PCl3 plus 3H2O will give H3PO3 plus 3HCl. It reacts with organic compounds containing OH group such as CH3COH or C2H5OH to give that मतलब क्लोरीन ऐड कर देगा क्योंकि PCl3 था। हेलो कंपाउंड बना देगा। It has pyramidal shape as shown in which phosphorus is sp3 hybridized. Phosphorus pentachloride, trichloride भाई, trichloride. Phosphorus is preparation. Phosphorus pentachloride is prepared by the reaction of white phosphorus with excess of dry chlorine. P4 plus 10Cl2 will give 4PCl5. It can also be prepared by action of SO2 SO2Cl2। पहले SOCl2 था, अब SO2Cl2 होगा, तो यहाँ पे भी 10 लगाएंगे, वही बन जाएगा हमारा। Properties: PCl5 is yellowish white powder and in moist air it hydrolyzes to give POCl3 and finally it gets converted into phosphoric acid. PO4, इसमें एक ऑक्सीजन फालतू है, वो सारे मतलब। When heated it sublimes but decomposes into stronger heat on stronger heating. पहले उड़ जाएगा, उसके बाद ये बन जाएगा। It reacts It reacts with organic compound containing OH to converting into chloroderivative. Finely divided metals on heating with PCl5 give corresponding chlorides. 2Ag plus PCl5 will give 2AgCl plus PCl3. Sn plus 2PCl5 will give SnCl4 plus 2PCl5. It is used in the synthesis of organic compounds like C2H5Cl and CH3COCl. In gaseous and liquid phase, it has trigonal bipyramidal structure as shown. ठीक है. The three equatorial PCl bonds are equivalent, while those of two axial are longer than equatorial bonds. This is due to the fact that the axial bond pair suffer more repulsion as compared to equatorial bond pair. In the solid state, it exists an ionic solid PCl4 plus and PCl6 minus, in which the cation PCl4 is tetrahedral and an ion is octahedral. Why does PCl3 fumes in moisture? ये react करके H3PO3 बन जाते हैं. Are all the 5 bonds of PCl5 equivalent? No. Equatorial छोटे होते हैं, axial लंबे होते हैं. What happens when PCl5 is heated? PCl5 को heat करते हैं तो PCl plus Cl2 बन जाता है. Yep. PCl3 plus Cl2 वही बोलना चाह रहा था. Write the balance equation. ये यहाँ पे लिखा हैवी वाटर D2 लिख देंगे H2 की जगह. ऑक्सो एसिड्स ऑफ फॉस्फोरस कितना रहेगा? ओके, जैसे 2 पेज. Phosphorus forms a number of oxoacids. The important oxoacids of phosphorus, with their formula, method of preparation, and presence of some characteristic bonds, is shown below. अब इनके स्ट्रक्चर हम बनाते जाएंगे. बनाते रहते हैं. क्या है? बोलते हैं थिकनेस घटा लेता हूँ थोड़ी. हाँ, तो पहले P के साथ एक डबल बॉन्ड डाल देंगे. लिख नहीं रहा वहाँ पे. फिर एक OH बच गया. बाकी के H और H. फिर P डबल बॉन्ड O. फिर 2 H बचे इस बारी. तो एक चीज का ध्यान रखो, जब भी P और O आ के साथ में तो P कम से कम एक डबल बॉन्ड O तो कर देगा. उसको प्यार है ऑक्सीजन के साथ डबल बॉन्ड बनाने में. यहाँ पे भी ऐसे ही करेंगे. बीच में जगह छोड़ देंगे क्योंकि पता नहीं कि POP आएगा या नहीं. डबल बॉन्ड O. अभी कितने बचे हमारे पास? 3 बचे. तो एक यहाँ पे लग जाएगा OH. एक यहाँ पे लग जाएगा OH. फिर एक O बीच में आ जाएगा. इसकी वैलेंसी भी सेटिस्फाई हो जाएगी. अब P2O5H4. H4 हमारे हो गए ना. अच्छा, यहाँ पे H है एक ऑक्सीजन का. हाँ, अब आई गेस तो. हाँ, यहाँ पे वैसे इन्होंने लिखना चाहिए था कि एक POP बॉन्ड भी है. तो इधर भी वैसे ही बनेगा. यहाँ पे 2 ऑक्सीजन आ जाएंगे, पर ऑक्सो लिंकेज हो जाएगी यहाँ पे. यहाँ पे 1 PP है. हाँ ठीक है, इवन नंबर ऑफ ऑक्सीजन हो गए ना अब. तो दोनों तरफ में 2 2 OH आ जाएंगे. हाँ. इसकी प्रिपरेशन भी एक और देखते रहते हैं. H3PO2 वाइट फॉस्फोरस प्लस एल्कली. H3PO3 P2O3 प्लस वाटर. फिर H4P2O5 PCl3 प्लस H3. सॉरी यार, लाइट चली गई थी तो कंप्यूटर बंद हो गया अचानक से. मैं दोबारा से खोल रहा हूँ. गिव मी अ मिनट. सारे एडिट्स भी शायद से डिलीट हो गए होंगे उसमें. मतलब जो भी मार्किंग की थी ना, हो गया ना? सब गया। क्या क्या ही कर सकते हैं अभी। ऑब्जर्व पे थे ना फोस्फोरस के। स्ट्रक्चर बनाना तो आता ही है। हाँ, तो वाइट फोस्फोरस प्लस अल्कली से बनेगा हमारा H3PO2, P2O3 प्लस H2O, इट विल गिव H3PO3। फिर PCl3 प्लस H3PO3 विल गिव H4। अरे ऐसे क्या बोल बोल के कहाँ याद होगा ये, लिख के ही करना पड़ेगा। H2PO3 लिख लिख के ही करना पड़ेगा यार ये। चलो एक बार फॉर्मूलाज देख लेते हैं बस। लेकिन पायरो हो गया H4P2O7, ऑर्थोफॉस्फोरिक एसिड H3PO4, हाइपोफॉस्फोरिक एसिड H4P2O6, पायरोफॉस्फोरिक एसिड H4P2O5। अरे वाह, स्ट्रक्चर यहाँ पे बनाए हुए हैं क्या यार। The composition of oxo acids are interrelated in terms of loss or gain of H2O molecules or oxygen atom. The structure of some important oxo acids are given below. H3PO4, अच्छा, तो इसमें से H और H2 हट गया और डबल हो गए, राइट? यस। इसमें से फिर ऑक्सीजन घट गया, एक एक और ऑक्सीजन घट गया। ऐसे से करके क्या करना। In oxo acids, phosphor in oxo acid, phosphorus is tetrahedrally surrounded by other atoms. All these acids contain at least one P double bond O bond and one POH bond. The oxo acid in which phosphorus has lower oxidation state, that is less than +5, contain an additional P double bond O and P bond OH bonds, either PP, example in H4P2O6, or PH, example in H3PO2 bonds, but not both. या ये होंगे या ये होंगे। These acids in +3 oxidation state of phosphorus tend to disproportionate at higher or lower tend to disproportionate to higher or lower oxidation state. Okay, +3 वाले higher और lower में चले जाते हैं। For example, orthophosphoric acid और phosphorus acid, ऑर्थोफॉस्फोरिक एसिड हो गया हमारा ये वाला। It on heating disproportionate into ortho, अच्छा phosphorus से चला गया phosphoric acid and phosphine। Okay, these acids which contain pH bond have strong reducing properties। pH bond have strong reducing properties। अलग पंगा है इसका। हाँ, thus hypophosphorus acid is a good reducing agent as it contains 2 pH and reduces, for example, AgNO3 to metallic silver। Okay, this is a good reducing agent क्योंकि इसमें दो दो होते हैं pH bond। These pH bonds are not non-ionizable to give plus H and do not play any role in basicity. Thus, those H which are attached with oxygen in POH forms the ionizable and cause the basicity. Thus, H3PO3 and H3PO4 are diabasic and tribasic respectively, as the structure of H3PO3 has 2 POH and H3PO4 has 3. How do you account for the reducing behavior of H3PO2 on the basis of their structure? इसमें हो गया P डबल बॉन्ड O, फिर एक POH और दो PH बन गए, जिस वजह से इसका reducing character आ गया। Basicity of this is 2, highlighted 2 ही होगा, नहीं 3 होगा। और what happens when this is heated? It will decompose into H3PO4 और हाँ हाँ, प्लस PhD। चलो, आज के लिए बस खत्म करते हैं यहाँ पे। तो कल ये आगे करेंगे, मतलब 16 और 17 कल के दिन में कर लेंगे। और ग्रुप 18 और लिक्विड सॉल्यूशन परसों से शुरू कर देंगे। वैसे मैंने चैनल के पोस्ट टैब में डाल दिया आगे की रूटीन कैसी होएगी इस सब की। मतलब ये क्या कहते हैं, लाइव स्ट्रीम कब कब किस किस दिन की होगी, तुम लोग देख सकते हो वहाँ पे। बस आगे लिक्विड सॉल्यूशन के साथ मैं ग्रुप 18 डाल दूंगा। ग्रुप 18 4-5 पेज का ही है, तो 10 10 एक मिनट लगेंगे शायद उसे। अभी 1 घंटा हो गया 16 पेजेस पे। तो मिलते हैं कल। बाय बाय। यार शाम को वैसे मैं देखता हूँ EMI करूंगा रात के टाइम 7-8 बजे।